My name is Siddharth Srivastava, and today I am going to present my presentation on the topic application of finite automata in networking. So, first we will know what is an automata. Theory of automata is a theoretical branch of computer science and mathematics. It is a study of abstract machines and the computation problems that can be solved using these machines. The abstract machine is also called the automata. The main motivation behind the developing of automata theory was to develop the methods to describe and analyze the dynamic behavior of discrete systems. And this system consists of states and transitions. The states are represented by circles and the transitions are represented by the arrows. As we can see on the right side, there is a picture which shows the states Q0, Q1, Q2, and Q3. And these are the circles which represent states. And the Q3 is represented by double circle, which means this is a final state. And Q0 has an arrow, which means it is the starting state. So automata is the kind of machine which takes some string as input, and this input goes through a finite number of states and may enter in the final state. So suppose like this machine is this finite automata accepts the input 101. So we have drawn this automata using states and state transitions. So we will now go to the brief history about automata. Like the theory of abstract automata was developed in the mid 20th century in the connection with finite automata. Automata theory was initially considered a branch of mathematical systems theory, studying the behavior and discrete parameter systems. Early work in automata theory differed from previous works on systems by using abstract algebra to describe information systems rather than the differential calculus to describe mathematical systems. The theory of finite state transducer was developed under different names by different research communities. Also, the earlier concept of Turing machine was also included in the discipline along with new forms of infinite state automata such as push-down automata, which is and Turing machine and push-down automata have has a wide range of applications in today's world. So let's move further. And now finite automata is classified into two types: finite automata with output and finite automata without output. So finite automata with output consists of Moore and Mealy machine, whereas with finite automata without output consists of DFA, NFA, and epsilon NFA. So we will now study about the applications of different automata such as finite automata, push-down automata, and Turing machine in theory of computation. First, we will study about finite automata application. It is used in various fields such as design of lexical analysis of a compiler, used for spell checkers. It is also helpful in text editors, and it is also used in Mealy and Moore machines for designing combinational and sequential circuits, which we use in electronics subjects. And let's move further. Now we come to push-down automata. The application of push-down automata includes the implementation of stack applications used in the syntax analysis phase, used in the evaluation of arithmetic operations, and it is also used to solve the Tower of Hanoi problems. And let's move further. Now we come to Turing machines. It has wide variety of applications, such as it is used for knowing complexity theory, used to solve the recursively enumerable problem, used for neural networks implementation. It has also a great application in robotics application and used in implementation of artificial intelligence also. Now we will see the various applications of automata theory. So automata theory is used in real life fields such as in compilers, interpreters, parsers, and natural language processing and text processing, finite state machines, are often used in AI side of the game programming and to develop the solutions of constrained programs in search engines, and search algorithms also plays a huge part. And most importantly, it is the heart of the TCP/IP protocol. It is also a finite state machine, which we will study further, which we will see how it works in the networking problems. So now let's come to the application of automata theory in networking. So automata is a basic structure in computer science. So it has various applications in networking. Automata theory is a branch of theoretical computer science that deals with the study of abstract machines and computational problems they can solve. In the field of networking, automata theory has several applications, such as it is used in network verification, network modeling, packet classification, security, etc. So these overall, we can say that automata theory simply plays a crucial role in the design, analysis, and implementation of network systems by providing a formal framework for modeling and verifying the behavior of these systems. Let's move further. Till now we discussed various fields by which automata theory is used. But now we are going to discuss in specific that how the automata theory is used in the networking and communication. Various protocols used by automata theory networking are error control, flow control, and bandwidth limitation. So let's go further. To solve these problems, we require the definition of one or more communication protocols, that is, shared conventions for the transmission of data in one direction and acknowledgements received in other ends. So rather than attempting to describe all of the required functionality as a single protocol, it is now common practice to provide a protocol stack. So in automata theory, while we use in networking, it is now common practice to provide a protocol stack. Protocols at layer n of the stack make use of functionality provided at layers n-1 and below. The Internet Protocol stack has 5 layers, which we'll see now. So see, these are the 5 layers in the picture. We can see application, transport, network, link, and physical layer. We have also the right side image shows the various uses of these 5 layers, like application, transport, network, link, and physical. And these also contain some internal protocols like HTTP and TCP, UDP, which is a part of computer network subject, which we will not discuss here in detail. So now we will see how can we apply automata in this protocol. So the finite state models of the sender and receiver using this protocol are very simple. So in constructing these models, we assume that there is a higher level process on one side that invokes the sender when it has data, send, and a higher level process on the other side that will be notified to receiver whenever data arrives. So it is quite interactive. This protocol is quite interactive from within the user. Although we don't handle this part of the process in the models we are about to build, we can note that the sender will maintain a FIFO queue of messages that it has been told to send the message at the head of that queue. The FIFO refers to first in, first out. So let's move further. So the most important protocol used by automata in the networking is stop and wait protocol. The automatic repeat request ARQ, which is also known as automatic repeat query, it is an error control method for data transmission. It uses acknowledgements that these are the messages sent by the receiver, indicating that it has correctly received a message, and timeouts. Timeouts are specified periods of time allowed to elapse before an acknowledgement is to be received to achieve reliable data transmission over an unreliable communication channel. So ARQ is appropriate if the communication channel has varying or unknown capacity. If the sender does not receive an acknowledgement before the timeout, it retransmits the message until it receives an acknowledgement or exceeds the predefined number of transmissions. So this is a positive point of this protocol. So as we can see in the diagram, we have a sender and receiver. These horizontal lines represent the timeout, and sender here is sender has sent data to receiver, and an acknowledgement has been and it has been acknowledged by the receiver. So again, it retransmits the data to sender, and in this way the process continues. So let's move further. So from these slides, we conclude that we have seen many systems operating in practice can also be modeled by finite automata, such as control circuits of computers, communication protocols, lexical analyzers for compilers. It is generally agreed that finite automata are a general medium to describe dynamic behaviors of reactive systems. Finite automata are formal and rigorous, and computer programs can be easily written to simulate their behaviors. To model a reactive system with finite automation, first the states the systems goes in or the modes of its operations are identified. These become the state of the finite automation that models it. Then the transitions between the states triggered by events and conditions, external or internal to the system, are identified. They become arcs in the transition diagram of the finite automation. In addition, actions that may take place in those states can also be added to the model. So, in the presentation, we have seen that there are a lot of use of the automata theory in modern world, especially in the networking part. So I would like to thank you to see my presentation. Thank you.